Hi everyone, I am Zahid as a host for the science show today. For today, the experiment is about electromagnetic wave. The title for this experiment is the wireless power transfer. In this experiment, the law that we will learn is Faraday law and Ampere's law. Now, I will call Prof. Atirah to explain the experiment in detail.
Thank you, Mr. Zahid. This project is using electromagnetic power transfer. The electromagnetic power transfer is a transmission of electrical energy from one place to another without using wires. In wireless power transfer, a wireless transmitter will connect to a power source and transmit the field energy, which is a magnetic field. Then the power is transferred by magnetic field using inductive coupling between coils of wire. And now there is two laws in this experiment, which is a Faraday's law and Ampere's law. Faraday's law is a basic law of electromagnetism on how a magnetic field will interact with an electric circuit to produce an electromotive force. Next is Ampere's law. Ampere's law states that for any closed path, the sum of the length element times the magnetic field in the direction of the length element is equal to the permeability times the electric current enclosed. This is a circuit emitter diagram, and this is a diagram how the magnetic field happen. And that's all from me.
Okay, let's move to our demonstrator for today. What is going now, Fadilah?
Today I will explain about the components for the experiment. Firstly, we have the coils of the copper wire. The purpose is to produce the magnetic field. Second, we have the battery. The battery will act as the power supply. Then we have the LED. The LED is used to emit visible light from an electric current pass to it. Okay. Then lastly, we have a transistor. The transistor will use to amplify the switch, electronic signal, and electrical power. That's all.
Okay, thank you, Fadilah. Oh, that sounds so interesting. Can you show our audience how the experiment works?
Thank you, Zahid. Yeah, sure. I can show you guys. The first thing you need to make is the emitter coil. For this, you need a bottle that is about 1.5 inches diameter. Then you have to take the magnet wire and make 12 turns around the bottle. After the first 12 turns, take a wire, then make a twist in order to have a center tap. Then make another 12 turns. Cut the wire, and now we have 3 connecting points. The first starting point, center tap, and end point. This is the result of the emitter coil. We have center tap point, starting point, ending point. After you finish the coil, put some tape in order to avoid unwinding. We are going to connect the center tap of the coil to the positive of the battery and 2 other wires of the coil to base and collector of the 2N22 transistor. The emitter of the transistor goes to the negative. The receiver coil is made in the same way as the emitter coil, but you don't have a center tap. It's used 24 turns of wire, and you have to connect an LED in 2 end points. Now we are ready to test. Here's the emitter coil, and here is the receiver coil. Now we are ready to test. Here's the emitter coil, and here is the receiver coil. We bring the receiver coil to the emitter coil to see the LED is light up or not. The LED is light up, but it has low brightness due to some of the lower number of turns of coil. Now, switch off the lights. And it's done. The LED is light up. You guys must be wonder how this experiment works. When we connect the battery to the stick with the current circulate through the coil and the magnetic field is formed. When battery is disconnected, the magnetic field collapses. The function of the transistor is to connect and disconnect the battery thousands of times per second. Therefore, we have a magnetic field that is created and collapsed continuously, so we have variable magnetic fields.
Now, we have Ishamuddin to conclude the experiment.
Okay, thank you, Mr. Okay, now I will conclude the whole experiment. The first conclusion is, the closer the first coil to the second coil that have transistor, the brightness will increase. And the second one is, this can be proved by the theory of this experiment, which is the use of electromagnetic power transfer. The electromagnetic power transfer is the transmission of electrical energy from one place to another without using wires. And the third one is the increases number of coil, the brightness will increase. Okay, then before we want to do our experiment, we need to know some precaution, which is number one is make sure wrap the end of the copper wire using sandpaper. And the second one is number of the coil must be equal. And the third one is to avoid unwinding coil, we need to wrap by using tape. Okay, thank you. That's all for me.
Okay, that's all for today's show. Thank you everyone, and I hope you enjoy for this show. Okay, thank you.